Time travel. It's a concept that's fascinated humans for centuries. From ancient myths to modern blockbusters, the idea is everywhere. But what does science actually say? Could we really jump through time like skipping chapters in a book? Let's break it down. For real. First, we have to ask, what is time? We treat it like a river, flowing forward, always moving. But time isn't a constant. It's a dimension, just like length, width, and height. According to physics, time is part of the very fabric of the universe. And that fabric can bend. Time can stretch. And time can snap. In 1905, Albert Einstein changed everything we thought we knew about time. His theory of special relativity showed that time isn't fixed, it stretches and shrinks depending on how fast you move. Imagine two people, one standing still and one flying near the speed of light. To the traveler, time moves slower. Their seconds stretch, while back on Earth, clocks tick normally. It's not just theory, it's been proven. Astronauts aboard the International Space Station age slightly slower than we do down here. The effect is small, milliseconds, but measurable. And the faster you move, the more extreme the effect becomes. If you could fly near the speed of light, you might experience a few hours while years pass back on Earth. That's why they call it the twin paradox. Einstein didn't stop with speed, he also proved that gravity can slow down time. The stronger the gravity, the slower your clock ticks. That means time moves slightly slower at sea level than it does on top of a mountain. It's a tiny difference, but it's real and measurable. Near a black hole, the effect becomes extreme. Time almost freezes. In theory, you could orbit one for minutes and come back to find decades have passed. The closer you get to intense gravity, the more time slows down. Not metaphorically, but literally. Astronauts in deep space would age slower than everyone back on Earth, simply because of where they are. You don't need a time machine, just the right gravitational field. Gravity doesn't just pull on matter, it pulls on time itself. So what about going backward in time? Some scientists believe it might be possible if wormholes exist. A wormhole is like a tunnel through space and time. Think of it like folding the universe in half and punching a hole through. If one end was kept still and the other moved near light speed, time would pass differently on each side. That could create a portal, one side in the future, one in the past. In theory, you could step through and arrive before you even left, but there's a catch. Wormholes are unstable. To keep one open, you'd need something we've never found: exotic matter. Exotic matter isn't just rare, it may not exist at all. Let's say you went back in time and prevented your grandparents from meeting. Would you still exist to go back? That's the core of the grandfather paradox. If you erase your past, do you erase yourself? Some physicists think it's impossible, that reality wouldn't allow it, but others think paradoxes are avoided because new timelines are born. Every change you make creates a new version of reality. You don't rewrite your past, you branch off into another future. Your original timeline still exists, you just stepped away from it. And that might be the universe's built-in solution to time travel. Is the crazy part, time travel isn't science fiction, it's already happening. Satellites in orbit experience time slightly differently than we do on Earth. That difference, called time dilation, is small but measurable. If we didn't correct for it, your GPS would be totally wrong. That correction is built into every GPS satellite orbiting our planet. In fact, astronauts aboard the International Space Station have already traveled through time. Technically, their clocks move just a little slower than ours because they're moving faster. It's not a time machine, but it's still time travel, and all of it, satellites, clocks, astronauts, proves that Einstein was right. Time isn't fixed, it's flexible, and it's already being bent every single day. So, can we time travel into the future? Absolutely. But we've already done it through motion, through gravity, and through precision science. But going backward, that's where it all breaks. You'd need impossible amounts of energy or break the laws of cause and effect. The universe seems to protect its past from us. Every theory we've explored still hits a wall. But what if we're thinking about time completely wrong? What if time isn't a line, but a landscape? Because the deeper we go into time, the stranger it gets. And maybe time isn't something we move through, it's something that moves through us. So what do we know? Time isn't fixed, it bends, it warps, and sometimes it slips. And while we may not have built a time machine, we're closer than we think. Thanks for watching. If this blew your mind, you know what to do. We're just getting started, and time is on our side. This is TopTech Insights.